Next, state and prove conjugate functions property. So first we write down the statement here. If x of t Fourier transform is xf, then for complex valued function conjugate is its Fourier transform capital X conjugate f. So here this sign indicate complex conjugate. It indicates complex conjugate, means complex conjugate of capital X and x of f and x of t. So now we write down the proof for this. According to the definition of inverse Fourier transform, inverse Fourier transform, x of t is equal to minus infinity to infinity x of f e raised to j 2 pi f t df. This is equation number 1. So we take the complex conjugate of both sides. Take complex conjugate of both sides. So complex conjugate of x of t, it is integration minus infinity to infinity xf e raised to plus j 2 pi f t df, its complex conjugate. Now note that the complex conjugate of this e raised to j 2 pi f t is e raised to minus j 2 pi f t. We write here complex conjugate of e raised to plus 2 pi f t is e raised to j 2 pi f t, is e raised to minus j 2 pi f t. So we write the complex conjugate of x of t is equal to minus infinity to infinity df. This is equation number 2. Now we replace f by minus f. Replace f by minus f. So where in equation 2? In equation 2. So equation 2 becomes complex conjugate of x of t minus infinity to infinity minus f e raised to minus j 2 pi f t df. This is equation number 3. Here we replaced minus f by plus f, so it becomes plus. Okay. So we write RHS of equation 3 indicates inverse Fourier transform of x of f is conjugate x of conjugate is x of t conjugate. Therefore inverse of complex conjugate of x of minus f is x of complex conjugate of x of t. So we can write as Fourier transform minus f. Fourier transform has conjugate property, that is xf is equal to complex conjugate of x of minus f. Next is duality or symmetry property. Next is duality or symmetry property. So state and prove duality or symmetry property. So statement for this, first we write if xt its Fourier transform is x of minus f, then x of t its Fourier transform is x of minus f. So here x indicate the shape of the signal, that is small x indicates shape of the signal, and t is time variable. We write here in x of t, x indicate shape of signal, and what is t? T is time variable. T is time variable, that is x of t means shape of signal is function of time. Shape of signal is function of time, and in x of minus f, here x indicates shape of signal in frequency domain. Shape of signal in frequency domain, okay, and it is called as a spectrum, and f is here frequency variable. F is here frequency variable. So we write down the proof for this now. Now according to the definition of inverse Fourier transform, according to definition, statement is only this one, okay. These are the key points. Now, or we can say meaning of the notation. This is according to definition of inverse Fourier transform, x of t is equal to minus infinity to infinity x of f e raised to j 2 pi f t df. This is equation number 1. Now replace this t by minus t in equation 1. replace t by minus t in equation 1. Therefore x of minus t minus infinity to infinity x of f e raised to minus j 2 pi f t df. This is equation number 2. Now here t and f are dummy variable and we can interchange it. We write here t and f are dummy variable which can be interchanged, so interchange t and f in equation number 2. So we can write this equation as x of minus f is equal to integration minus infinity to infinity x of t is to minus j 2 pi f t. It is as it is dt, equation number 3. So we compare equation 3 with the definition of Fourier transform. We write here compare equation 3 compare equation 3 with definition of Fourier transform. We can say Fourier transform of x of t is x of minus f. Therefore x of t, its Fourier transform is x of minus f. Now the shape of the signal in time domain and frequency domain can be interchanged. Here dummy variables are used and we can interchange this dummy variable. So from this we can say the significance as the shape of the signal in the time domain and the frequency domain can be interchanged. So we have seen all the properties like linearity property, time scaling property, time shifting property, area under curve xt property, area under curve x of f property, frequency shifting property, differentiation in time property, integration in time property, multiplication theorem, convolution theorem, conjugate function and duality or symmetry. So these 12 properties and its proof we have seen. Now the next is problem based on these properties of Fourier transform. So we write down the first problem here. Problem based on these properties of Fourier transform. So first problem is obtain Fourier transform of x of t equal to d by dt of e raised to minus at u of t, given that e raised to minus of mod t, its Fourier transform 2 divided by 4 pi square f square plus 1. So this is the problem. We have to obtain the Fourier transform of this x of t. So first we write down what is given. Given is that x of t is equal to d by dt of e raised to minus at u of t. So we have e raised to minus at u of t, its Fourier transform 1 by j2 pi f plus a. We have already seen all the properties. So according to differentiation in time property, we write here according to differentiation in time property. So we can write d by dt of x of t, it is j2 pi f into x of f. So we can write Fourier transform of, therefore Fourier transform of d by dt of e raised to minus at u of t equal to j2 pi f divided by j2 pi f plus a. Now the next problem. Determine the Fourier transform of the given signal, that is x of t equal to e raised to minus 3 mod of t. So first we write down what is given. Given is xt is equal to e raised to minus 3 mod of t. Now we will decide the nature of signal by putting different values of t. Okay, so that we can find the nature of the signal. We write here by putting different values of t, we can decide nature of signal. So for t is equal to 0, we can write x of 0 is equal to e raised to minus 3 mod of, it is e raised to 0 equal to 1. And for negative values of t, t is equal to minus 1, so it is x of minus 1, it is e raised to minus 3 mod of minus 1, it is e raised to minus 3. Similarly for minus 2 and for minus 3, so we can write this as x of minus 2, so of minus 3, it is e raised to minus 3 into 2, so it is e raised to minus 6, e raised to minus 9. Now next is for positive values of t. For positive values of t, so t is equal to 1, 2 and 3. So it is x of 1, x of 2 and x of 3. It is e raised to minus 3 of 1, e raised to minus 3 of 2 and e raised to minus 3 of 3. So this equation becomes e raised to minus 3, e raised to minus 6, e raised to minus 9. From these values we can draw the signal. So it is x of t it's 0, 1, 2, 3, it is minus 1, minus 2 and minus 3. This is e raised to minus 9, e raised to minus 6 and e raised to minus 30. So for minus 1, for minus 6, so this is the nature of the signal. Now it is double-sided exponential signal. These signals are exponential signal, but it is double-sided signal. So we write here, it is double-sided exponential pulse. So mathematically we can write x of t is equal to e raised to plus 3t u of minus t plus e raised to minus 3t u of t. Therefore, x of f is equal to 1 by 3 minus j2 pi f plus 1 by j2 pi f plus 3, which is equal to, we solve this equation, j2 pi f plus 3 divided by 9 minus j square 2 pi f square. So x of f is equal to 6 pi plus 2 pi f square. So this is the answer. Now the next problem is find Fourier transform of d by dt of e raised to mod of minus t. So according to differentiation in time property, we write here, according to differentiation in time property, Fourier transform of d by dt of x of t equal to j2 pi f x of f, or we can say j omega x of omega. Therefore, Fourier transform Fourier transform of d by dt of e raised to minus of mod of t, it is j2 pi f into 2 by 4 pi f square plus 1, that is j 4 pi f divided by 4 pi f square plus 1. So the previous problem, that is this problem, was asked in exam for 6 marks.